Hello and welcome to today's webinar. I'm your moderator, Devin Tackles. I am part of DroneDeploy's marketing team, and I'm excited to have you joining us today to talk about generating actionable insights with drone data. This is another installment of our ongoing agriculture webinar series, so thank you for joining us today. Now, we often talk about actionable insights, but how do you obtain them? And once you have made a discovery, how do you turn that data into action in the field? That's what we're going to dig into during today's session. Plants are already beginning to emerge across the US, and it's prime time to put drones to work. We hope you leave today's webinar with better insight into how you can leverage some of the latest drone software and hardware to be successful in the field this growing season. So let's go ahead and get started. Let me introduce today's panelists. To kick things off, we'll hear from DroneDeploy's own Ian Smith. Ian Smith works on our business development team and leads our app market. He started his career as a commercial helicopter pilot and flight instructor, but pivoted towards robotics and automation. Ian is also the founder of Commercial Drones FM, a tech media company which produces a podcast that helps listeners explore the people, concepts, and business of commercial drones. Then we'll hear from Milan Dobrota from Agremo. He has over 17 years of experience in the information technology and software industry and is the founder and CEO of Agremo. Besides his software engineering background, he holds a PhD in data science, specializing in remote sensing. And last but certainly not least, we'll hear from Matthew Berry of SlantRange. He leads strategic development at SlantRange and now oversees all sales, marketing, business development, and strategy for the company. Prior to joining SlantRange, Matt held several program management and business development positions at General Atomics, producing imaging and optical sensor systems for unmanned aircraft. Before we get underway, I have a couple of housekeeping announcements to share. We'll be recording this webinar and providing all attendees with a copy of today's presentation slides. So sit back and enjoy today's presentation. Let's go ahead and get started. So, what are we going to be talking about today? We're going to hear from Ian, as I mentioned. He's going to talk a little bit about DroneDeploy and how you can leverage DroneDeploy's app market all season long. And then we're going to hear from Agremo and how you can generate crop insights with their app and technology. Then we'll be moving beyond NDVI with SlantRange and Matt. And we'll end the webinar with a short Q&A session. So if you have questions that come up throughout the presentation, please use the chat box within your GoToWebinar control panel to submit those questions. We'll be getting to as many of the questions that we can towards the end. And to kick things off, we like to keep these interactive. So we've got a quick poll. We're interested in hearing from you all and kind of getting a better understanding of who's on the webinar today. So we want to know what the most significant challenge you want to address this year with drones. We'll go ahead and leave this poll open for about 30 seconds. So please use the GoToWebinar control panel to submit your answer. All right, the results are pouring in. Go ahead and leave it open for another 5 seconds or so. So if you haven't answered, please do. All right, the results are in. So coming out in front is interpreting data to make decisions. Well, I've got good news for you folks because that's exactly what we're talking about today. Followed closely by gathering crop data. So that's something we'll also be discussing. Coming in third is improving efficiency of applications, which is something you can definitely use drone data and the software and hardware that we're talking about today to achieve. So with that, I'm going to go ahead and pass it off to Ian Smith, who's going to talk a little bit about DroneDeploy.
All right, good morning, everybody, and thanks for the intro, Devin. So first of all, I want to give everyone a brief overview of DroneDeploy. What is DroneDeploy and how can it be used? And then kind of the ecosystem that we've started to create, but we're a very important part of as well. And so first of all, here are some metrics on DroneDeploy. So essentially we are software. We're software that helps you manage your crops with drones and then be able to automate the flight, capture the data, and process it. And so some of the metrics and some statistics on that, since we really got started with this back in 2015, are 30 million acres of data mapped. That's a pretty big milestone. Our tens of thousands of monthly active users from around the world in 180 different countries regularly use DroneDeploy every single day to capture data of their fields, process it, and then kind of create all of those final data products so that you can start analyzing it and getting even more value for that. So interpreting the data and then being able to draw insights from that, which was on the that poll question. And so, as I mentioned, when we started this back in 2015, we didn't have this much area covered. And when I say we, I mean like the royal we, like all DroneDeploy users across the planet. And so each one of those little blue dots that you're seeing there is actually a DroneDeploy map of a field or a job site. So there's been, this is the latest map, and we've had some cool ones where you can see the transformation going across the whole world. But this is really kind of the proof in the pudding of the value of drones in agriculture, in construction, and in the variety of different industries that we kind of focus on and build our tools for. And so to really understand how to use DroneDeploy, if you are new, we try to make it as simple as possible. It's a 3-step process. You fly, you process, and then you analyze. So on the flying aspect, humans are much less adept at capturing consistent imagery than a robot is. And so these drones are very smart. We just send them controls. So first, you're going to want to ideally purchase a DJI drone because our application, our software, can control those and automate the flight. And then you'll just create a simple polygon around your field. Maybe you have a shapefile of your field existing already. Then you can upload that into DroneDeploy, and then it'll automatically create a flight plan. So you don't have to do anything else except turn on the drone, connect it to DroneDeploy, and then press a button, and then the drone will take off, and it'll fly around in the pattern that it's identified as the most efficient route and capture hundreds, maybe potentially even thousands of images of the field below it. And at that point, you move on to the second step. You go ahead and upload that and process that data to get your final deliverables. So you get your 2D orthomosaics, so those high resolution satellite looking images of your field. And then you get 3D models, elevation models. You can get plant health and different vegetation indices, NDVI, OSAVI, VARI, any kind of VI you really want. There is a step in here that's not listed, but it's a really cool feature called Live Map. This is something that while the drone's flying, even back in that first step that you see there, there's actually going to be a kind of, well, we call it live map. It's a live map of your field being created. And it's kind of like if the drone were a Xerox machine or a scanner going across your field, you'll kind of start seeing it appear on your mobile device in front of you. And so when corn can be 12 feet tall, or if you're looking for something specific in the field, you can even get some insights while the drone is still in the air. So moving back on, so once you've processed that final data, you can get even more deliverables. Then you move on to the final step, which is the analysis. This is where we have a lot of tools built into DroneDeploy to measure and annotate and kind of compare a lot of your different data. You can share this with your colleagues or your clients, and then you can kind of, do a lot of in-depth analysis on top of your drone data. And then so on the next slide, I'll show you a little bit about this ecosystem that I mentioned earlier, and then how to get even more value out of that drone data that DroneDeploy just isn't interested in working on. We want to make the best drone software to get the job done, and then we want to work with best in breed solutions to actually amplify that. And so starting at the very bottom there, we've got the drone hardware. Most of you probably know the company DJI. As I mentioned, you're going to want one of those hardware platforms in order to work really well with our software. And then the next step, looking above that, is DroneDeploy. And above that is where it really starts getting very, very interesting. So I lead this initiative called the App Market. I'll tell you a little bit more about it in the next slide. But through the App Market and through our APIs, you can connect to, you see Milan over here from Agremo, and then we've got Matthew here from SlantRange. You can use the integrations that their two respective companies have created to amplify your drone data in various parts of that 3-step process that we mentioned. And then they'll be going more into that as the webinar progresses. One level above that, we have even more integrations. So DroneBase and Uplift, those are ways that maybe you don't have a drone yourself. Maybe you might be intimidated. You don't want to deal with anything regulatory. You can use DroneBase or Uplift to kind of come to you and then fly their drones through their network of pilots over your fields to get the data. We also focus on, maybe you are ready to take the challenge, maybe you're ready to take the jump. You can use Dart drones. They're our preferred training partner. They can train you up, get you your Part 107 certificate, so you're flying legally and safely and compliant. And then droneinsurance.com is a partner that's upcoming. They're going to be providing drone insurance services through DroneDeploy. You can get hull insurance for your drone, which is very unique. You can get liability, sensor insurance, all kinds of stuff, and it's going to be built-in, integrated, and really easy to manage, and it's going to have some very favorable and preferential pricing in there too, and great coverage amounts as well. And so going back to the app market, so it's really cool to be able to say that our ecosystem has created, itself and has grown to the largest drone data app marketplace in the world. And so we launched this back in November 2016. Agremo, SlantRange, launch partners of ours. This grew from, we launched with 14 integrations, and now it's up to 78 different integrations. And on the left side, you can see that there's, some of the integrations there. So, for other industries, we've got Autodesk for construction and Box. Of course, we've got My John Deere. You see the Deere logo there. Climate Field View, that's a very interesting integration that's upcoming. Our team is currently at work with the climate team right now, building that out. So you'll be able to get drone data into climate. AirMap will allow you to get contextual airspace information. And then, of course, we see Agremo down there for getting really cool insights on your field, and then SlantRange as well, who can also, make great sensors so you can capture this very unique data that you can get like way more interpretation and value from. And so that's just the ecosystem. It's constantly growing. We're looking to, take your feedback on what integrations you want to see and what really can amplify the drone data to actually, keep making your job easier, more efficient, saving money, increasing yields, and be able to interpret that drone data and not just hand you a pretty picture. And so with that, I want to show you a little video here. This is actually how to access the app market from within DroneDeploy. So some of you may be DroneDeploy users and you've never discovered an app before. And so it's very easy. This video will restart now. There's a little app market icon in the top left of your DroneDeploy screen, whether you're on your desktop computer or on a mobile device. And then you can click on the app market. You can search by industry. So you could click on agriculture and see all the different types of integrations that are there to help you make more use of all this data, because it does no good just sitting in DroneDeploy if it can't get into your system of record, or where you keep, all of your kind of information for your business in the day-to-day operations. And yeah, you can install it very easily with just one click. And with that, we'll kick it over to Mr. Milan Dobrata of Agremo. So Milan, go ahead and take us away.
Hi, everybody. Thank you, Ian. Thank you, Devon, for introduction, and thank you, everybody, for joining us today. My name is Milan Dobrata, and I will tell you a bit more about Agremo. So we can start. So Agremo is a cloud-based software which uses insights extracted from drone collected imagery to improve agricultural processes. And we are actually active since 2015, and there are now more than 30 of us who are involved in helping people use drone data in agriculture. And since then, actually, we worked with thousands of people on every continent, and we analyzed around 100 plant types. And as you will see later, the benefits of it can be really amazing. Now, we are always concerned here at Agremo, and we want to discover what are the most challenging parts of using drone technology in agriculture. So that's why we prepared the next poll. Yes, so I think we'll leave it a bit, and so please choose your answers. Okay, so this is very interesting, and actually, this is what me personally, I feel the most important part, and that's understanding of what growers need and how you can help. And actually, I think that it's very important to understand that the expectations and to be able to combine the right set of tools and techniques. For instance, I mean, if one wishes to analyze the soil itself, then I guess he will have no luck for now, and it's a bit difficult to leverage the drone technology. But if you want to know more about the crop and the crop health and the number of the plants, this is where actually you will have much more to gain, and this is where actually Agremo can help. So we can advance to the next slide. Thank you for watching. So really quickly, why use Agremo analysis in agriculture? So basically, because what we do is offering you much more accurate information comparing to if you just do a field scouting or to any other tools that we tried. Results go beyond NDVI, they save time, more efficient plant monitoring is provided, they're easy to use, and they're minimizing the losses and input costs, and they provide actually much higher ROI. But let's see some examples how concretely this can be achieved. So please, Devon, you can advance to the next slide. So currently, user can choose actually from two different set of the analysis, which is related to plant counting and plant health monitoring. And to start with, actually, stand count and plant population, they are different. They actually both provide the number of the plants, but the stand count analysis, they are comparing it to the recommended or planned or expected the sets and showing the differences. In either case, actually, user gets a two-page report which with accurate numbers and information about the exact location of low-performing areas, which is very important, including the according shape file that can be used with different tools. So some of the other analyses are the stress analysis, weed, pest analysis, plant disease analysis, water stress analysis, and flowering estimation. So let's move on to see some of the examples. So here is one typical stand count report, actually, and this user wanted to count his corn while it was still in V3 stage. I think this example is actually from Europe, from UK, and you can see different sections of a report. So first one shows general information, and this is basically the basic data of the analysis entered during the submission. Then the section 2 is probably the key part of it, where you can see the difference between the number of plants in the field and the number of planted plants. And section 3 is actually a visual depiction of the results, which can be really important because farmers, they tend to be visual actually in understanding the results. The section 4 allows at one point or some point agronomists, and they can enter here recommendations or any other comment that they might have, so that it can also improve the actionability of the report and the results. And the section 5 and 6 are actually the two maps that show the exact location of all healthy or unhealthy areas, and it gives actually the accurate scouting map, which can then be used by to lead growers to all low-performing areas, and then to combine the analysis on the scouting on the field. So, next slide, please, Dan. So what were the main findings from this particular report? And as an example, it was actually that the plant numbers was significantly lower than expected. In this case, 32% below expected, which is actually a big loss. This example might be too radical, but this is the real example from the practice. So I think you all know that can really happen. And actually, the grower found that where the low-performing areas were, and was able to confirm this afterwards by going on the field. And which is most important, actually, that these numbers help him decide whether or not to replant. And with this kind of the emerging rate much lower than expected, then it's a legitimate decision to replant it to save the ROI because the cost of it are lower than predicted loss. You can advance, Devon, thanks. So just to show you quickly that actually it's not all about the corn. As I said, we analyzed around 100 plant types. So for instance, we have a case of analyzing and counting Christmas trees from Denmark, and then banana trees from Puerto Rico, actually, which was quite popular after Hurricane Maria. So you can read a lot of these stories on our blog, and I think that will show you how powerful using this technology can be. So, next slide. Okay, so here is another example of one of our reports. It's actually an example from Minnesota, and it's about plant disease analysis. So it was also performed on corn, and the user actually know that he had difficulties with disease and wanted more information on that. And in the case, it was actually the case of common rust. And in this report, actually, the second section shows that how much of the field is affected and to which extent. In this particular case, at 24.1% of the field showed potential sign of stress, and 10.34 showed a clear sign of stress, which means that altogether it's 34% of the field performing poorly due to this specific disease. Now, the thing is that actually sometimes today's technology can show which disease is present by just from the drone taken imagery. But the thing is that by knowing how much of the field is affected and by knowing exactly where the affected areas are, the grower is able to use this high-tech scouting map, and it helps him make the best possible decision from there on. So the result map shows exactly where the low-performing areas are. Next slide, please. So what this particular analysis told the grower is the exact location of problem areas as well as how large they are. And this data saves the grower a lot of time because the entire process is a lot faster than manual scouting, which means that you can do such analysis again at a later point in time to track the effectiveness of measures you applied. And of course, it's important to say that the scouting is great and it's absolutely necessary to go, but it's not necessary to go out in the field. And by combining this with drone data, then you actually get truly powerful results. Please advance, Devon. Okay, so just a few more things about the benefits of our analysis. So besides being able to deliver accurate results, there are a few other things that users appreciate about Agremo, such as that we work with around 100 crop types, so we are not strictly focused on the field crops, but it also includes corn, soybean, sugarcane, trees, actually, which are among the most popular ones. So there is no special drone required. So Agremo analysis work with every commercial available drone. There is no special sensor required because analysis also work with RGB, near, and multispectral cameras. Next slide, please. Yeah, so the process, I think Ian already explained a bit of the overall process on DroneDeploy. So this is no more complex than that. So it's very simple. After collecting the aerial data with any commercially available drone, such as DJI models, and then you process image by uploading them to DroneDeploy. And actually, once you have georeferenced image from DroneDeploy, you can use the Agremo app directly from DroneDeploy. You can go to Agremo web page and launch it from there. Next slide, please. Yeah, so the process of requesting analysis is also very straightforward. So again, after you install the app on DroneDeploy, then you just select the area that you want to analyze and you run it from there. You choose a type of analysis, of course, and then it's simple as that. But so even if you use the Agremo web app, you still need to use DroneDeploy to process each image. That's very important. So actually, so this is the technology is an add-on, so you cannot overpass or skip the step of uploading and processing your images on DroneDeploy. So, but on the Agremo web app, actually, you get access to a plethora of neat features as well, so such as a result layer and our map comparison feature, which is also an amazing tool for effective seasonal monitoring. But what is very good news is actually that we are actually working to make some of these features of the Agremo web app accessible directly from DroneDeploy, which will make it even simpler to use the entire technology bundle, and in this way the users will be able to gain even more value of the overall technology. Next slide, please. Yeah, this is, for instance, an example of how it looks like when you overlay the results of the Agremo analysis over your original map. So basically, it's a shape file that you can export. You can also upload it to other tool of your choice. And it will be very cool, actually. As I mentioned, we are working to have this also available directly from DroneDeploy for our users. So in this way, it will really be even more simpler to leverage the analysis that we do. Next slide, please. Yeah, so a few tips on the flight planning. Of course, the required quality of the image always can differ depending on what is the crop type, what is the growing stage of the crop. It's not the same if you just want to count the trees or you want to count corn plant. So, but to achieve the highest actually image quality, this is an example of what we recommend. So, which means the altitude of 50 to 75 meters, and the flight speeds from 2 to 10 meters per second, side lap 75%, front lap 80%, to fly during the middle of the day and to analyze, if possible, from V3 stage on, in case of corn. But I think that actually you are getting constantly, and many of these tips from DroneDeploy directly, and this is, I think that DroneDeploy is getting really good results and in really good support on this. Next slide, please. So as I said, the image quality is important, and again, it's not about also the resolution. Usually, it's needed for 10 centimeters or 5 inches for the plant to emerge above the ground to be clearly identified. And the more basically advanced drone operator among you know that this is very achievable, and it's no big deal to achieve this level of accuracy of the image actually anymore. So what we also provide, and we do also a lot of education. Lately, we started a newsletter series called Agremo Academy, so I can invite you to join the series, and you will discover more how to use Agremo and generally drone technology to support users in agriculture. So the next slide. So thanks. I think then now you will the awesome Matt Berry from SlantRange will take it over from here.
All right, thanks, Milan, and thanks to Devin, of course, and the rest of the DroneDeploy team for including us today, and thanks to everybody who's logged in to watch today. Devin, I think you need to give me control, right? All right.
Should be all set.
Okay. Okay, so real quickly, starting with what exactly it is that we do here at SlantRange. At our core, we are a software analytics company. We got started about 5 years ago, really leveraging our expertise in remote sensing and analytics, and of course, applying it directly to agriculture. That's really where we spend most of our time, and I'll obviously talk about that quite a bit today. However, when we did get started, obviously you need some sensors to generate this data. We were focused on multispectral technology. We kind of did a survey of the market to see what was out there, and we had the expertise to build our own, so we made the decision to do that. So we also provide our own multispectral sensors. This happens to be the 3PX, which I'll talk about a bit more later as well. And then finally, I wanted to mention that we now offer some customized data services. So that includes things like generating custom algorithms for specific use cases, but we also now offer a specific service that basically generates all of the data products that I'll tell you about today, but tracks them against individual test plots. So it's really a service we developed, obviously specifically for research applications and test plots, where we do all the data processing in-house, so you can collect the data yourself, or we can go out and collect it for you. We process those results, and honestly, the deliverable is usually a spreadsheet of metrics across the test plots. And I can talk a little bit more about that as well, but that's at a high level what we do here. So starting with SlantView, I'll get into the data products, but these systems generate a lot of data very, very quickly, and reducing that data to useful information in an efficient and also scalable way is something that we've been focused on from the very beginning. So I'll walk you through a couple of pieces of the way we do that. To start, we've developed our own map generation technique that requires only 20% overlap in your images. This is a sample flight plan up here on the screen, and you can see about 20% overlap there between the flight legs. The reason we do that really is trying to reduce the data volumes that are collected. That really accelerates the data processing. But when you look at traditional techniques, most of them are requiring about 80% overlap. So comparing those, for a comparable sensor trying to achieve comparable resolution and comparable data products, we can cover the same area and about 4 times as fast, or equivalently, you could say, covering 4 times the amount of area in the same amount of time. But perhaps more importantly, what that also means is that we're collecting 16 times less data. So you've got 4x in 2 dimensions. And that means a dramatic reduction in data volume that has to be processed at the end of the flight. And that's part of what makes our processing so fast. So here kind of walks you through our data processing timeline. Number one, it's done completely offline. So there's no uploading data to the cloud. It's a completely local processing solution. And number two, as I just mentioned, it's very fast. So a typical flight is processed in around 10 or 15 minutes. And once you process those maps and generate those results, you can take action right away while you're still there in the field. And importantly, you can take those maps and upload them to DroneDeploy and treat them as any other map that you may have generated within DroneDeploy. So some of those, post-flight analytics tools that Ian mentioned, with the sharing and the measuring and the annotation, some of these downstream analytics, those are all still supported in DroneDeploy. There's just kind of a different front-end data collection and processing workflow when you're using SlantView. So getting a little bit more into the actual data products we generate and this concept of moving beyond NDVI. We certainly feel that NDVI clearly has some value and has its place, but there's really so much more you can do with this very high resolution data that you can get from a drone. So this is just kind of graphically showing you the same plot of ground. It's a few rows of corn from typical resolutions of other imaging platforms. So here is a sample satellite image at 100 centimeter GSD. Here is a sample image of the same plot of ground from manned aircraft at 25 centimeter GSD. Just to explain that quickly, that's ground sample distance. A lot of people might call that resolution, but that basically means that each pixel is sampling 25 centimeters on the ground. And this is not to say that you can't do better than this with some manned aircraft, and others will be worse. This is intended to be just kind of typical. Point being is here is though that you can't see the individual plants, but when you move into this drone imagery at say 1 centimeter GSD, it's not just that this is incrementally better resolution and more pleasing to the eye, but you're into this entirely new regime of remote sensing where what we call the characteristic dimension, meaning an individual leaf in this case, your pixels are now smaller than that dimension, and that allows you to do some very unique things that you're just physically not going to be possible to do with some of these other imaging techniques. And that's really what we're focused on and what allows us to do these other metrics, as I mentioned, that really move beyond NDVI. An additional step we do here at SlantRange is some additional filtering, really. And because we have that multispectral content, meaning that we can look at the spectral signatures of everything in the scene, that allows us to filter out basically pixels or signals from other things in the scene, whether it's soil or debris or shadows or standing water. We can filter those out, and that does a couple of things for us. Number one, it dramatically boosts the signal to noise of the actual crop vegetation. But number two, it actually dramatically reduces, again, the volume of data that we're processing. So in most cases, we just throw out those pixels that are highlighted in gray there. We don't have to process them, we don't have to deal with them, and again, that's part of what makes our processing workflow so fast, which is, again, typically 10 or 15 minutes once you've landed. So we do produce things like NDVI, and you can imagine, with this high resolution and this back-end filtering, our NDVI measurements, are more accurate. You're not mixing those pixels with, say, soil again or debris or other things in the scene. There are techniques to adjust for that. Any of these indices that have, SA in their name, that typically means soil adjusted. So they're attempting to, reduce the effects of the soil in each of those pixels. But again, when you're down at this very high resolution that you can get from a drone, you don't need to do that. You can just, physically remove them, and then your measurements become that much more accurate. However, again, with this resolution and this multispectral data, we can produce, a whole suite of other data products that we would certainly argue are very high value, very unique, data products that are going to bring a lot of value to your farm, a lot of ROI that you're not going to be able to get from these other techniques. So things like stand counts. So we do what we call a positive stand count, meaning that we're physically counting each plant. We're not just looking for gaps. Plant size distributions, emergence fraction. You can read the rest there, but a whole host of other data products, and we are constantly adding more. Smart detection there is listed as well. I'm going to show you an example of that on the next slide, and that's really a tool that we developed to push out some of these capabilities to the user and allow users of our systems to kind of generate new tools on the fly. And I'll show you here how that works. So this is a wheat field in Idaho. This is our stress map here, which happens to be our 4-band version of NDVI, you could say. So NDVI is a ratio of 2 bands. This happens to be uses all 4 bands and tends to be a bit more sensitive. You can see obviously some variation in the field. But what I want to show you here is underneath that white square that hopefully you can see near that pond in the middle of the field. So that image is shown on the right now. And you can see here, number one, you get a feel for the resolution, but number two, you can see there's this kind of purplish weed in the field. So if I zoom in here, which you can do in the software, these are obviously screenshots from the software, you can get a good look at that weed. And number one, again, without this resolution, you're not going to be able to separate that weed from the background. But this smart detection tool allows you to sample a region of the image. So literally just, draw a red box around it and tell the software, hey, show me everywhere else in this image where you see that same spectral signature or that same, type of material in the field. And that's what's shown here. So we'll highlight any pixels that have that same spectral signature. And you can adjust the sensitivity of that filter, meaning, just by scrolling the mouse wheel, you can say, put some broader bounds around that match and show me what that looks like. Show me in a very tight match for that spectral signature. And you can kind of, visibly tune that filter to say, okay, yeah, it's grabbing most of those pixels that I can see here with my eye. And now if I zoom back out, you can see that it's selected all of the pixels in that image, again, that have that same spectral signature. But you can also tell it, hey, show me everywhere in my entire map where that's occurring. And so now that's what's shown on the left here. So just by training it on that one small section, you can now create a map across your entire field showing you everywhere where that weed is detected. And you can also store that signature, meaning, I want to save this, identify this particular weed. I can now look for that signature in other fields. I can come back to this field and compare the, how that progression of the weed is done. You can export this map on the left as a shapefile if you want to do any kind of precision spraying. So really, it's a pretty powerful tool that, again, pushes some of these capabilities out to the user and allows you to create new tools on the fly. I'll show you one more example here. This happens to be lettuce. So this is looking at our plant counting tools. Of course, this is done for corn, as Milan mentioned, typically early in the season, but for vegetable crops, this is a very common tool that we've seen users using to count plants. So again, kind of this 2-pane interface, but on the left, this is now not a stress map, but this is showing your population density across the field. So areas in red are lower population, areas in green are higher population. Part of that process, like I mentioned, is this separation of the crops from the background. Once we've done that separation, we can count the plants, which is shown here, but we can also do some unique things looking at plant size. So if I switch here, this is now a distribution of plant size in the field, and you can see it's quite different from the plant population itself. So you can really start to get some pretty unique insights here. So you can see here, this is plant count, this is plant size. I'm just switching between them here. But you can see, there may be areas that have high plant density, but they're small plants or vice versa. So really some very valuable information. Part of this workflow as well as identifying weeds. So again, separating that vegetation from the background, but then once we've done that, separating the different types of vegetation using that spectral content from the multispectral sensor. So this, believe it or not, is actually a weed map in this field. They had a pretty significant weed problem, and honestly, this use case was actually used to decide whether or not to actually go harvest this field or just to scrap it. You may guess from this image that they chose to scrap it. It wasn't worth, I should say, the labor to harvest it. So if I zoom in on the right here, you can see here the lettuce heads and then the weeds. So the weeds are highlighted in red, the lettuce heads are highlighted in green. And again, you can see how that spectral content is used to do that separation. And then if I zoom back out, you can see that, of course, all the plants have been highlighted and counted, and then all the weeds have been identified as well. So with all that said, we were certainly curious to see if data products like that are of interest to you. Going beyond NDVI, as we've said, is this interesting? I got a few answers here. More data the better. There's certainly some folks in that camp. Yeah, it looks good, but I wouldn't know what to do with it. Yes, looks interesting, but I've got my own problems. Or no, NDVI is all I need. So we'll give you guys a little bit of time here to fill those out, and I'm curious to see the results. Right. All right. Well, interesting. I guess that's good news for us. More data, the better. I guess those are probably the folks that chose to tune into this webinar, but that's certainly promising. The second one is probably not all that surprising either. I think there's probably a bit of data overload going on in this space right now, which is we're trying to clear through some of that haze and pretty low responses on the rest, which I guess is good. So we'll move on from there. Okay, so I mentioned this briefly in the beginning. I don't have too much time to go too deeply into this, but again, this is a service that we're providing. Again, primarily for research customers. As I mentioned, you can fly this data yourself, or we can fly it for you. The data comes back to us, and then we run those analytics. Very similar to what I just showed you, but using a layout of your field and your plots, typically sent to us as a shapefile. We can now take those results and allocate them to individual plots and track them over time. So this is an example here of a single plot of corn that we've tracked from emergence up to tasseling. You can see the types of data products we're producing here. So just after emergence, you can see the population count there. Up through V4, we can do plant size measurements, and then beyond that, we start looking at vegetation fraction, which is kind of a proxy for biomass, various other indices there. And again, track individual test plots across the field. And again, as I mentioned, this is really along this concept of moving beyond into new data products. Our customers for this are typically interested in the imagery, and they may take a look at it. But again, the deliverable is typically a spreadsheet. So we're really going from a drone capturing high resolution on your field all the way to numeric data in a spreadsheet. There's obviously a lot of steps in between. But we're really, again, trying to focus on providing the real value that you can get from these systems, and in this case, again, supporting kind of research and breeding programs. If you're interested in that, we can certainly talk to you. Typical workflow is to answer a few questions about the number of sites and plots and flights that you're interested in, and we can quickly generate a proposal for you. So moving on from the software, as I mentioned, there's obviously a hardware component to what we do. So this is our family of products dating back to the 2P there shown in the back. The silver one in the middle is the 3P, and the black one is the 3PX. That's our latest sensor. I've got one sitting here. I can't see myself, but hopefully you can see this. So this is our 3PX. You can see the 4 cameras there. This is the critical point up here that I'll talk about in a minute, but this is some integration we did with DJI that I'll tell you more about. And importantly there, I won't go too deeply in this today, but on the right is our ambient illumination sensor, we call it, or sunlight sensor. And that's included with every one of our sensors. It's something we've been doing since we got started. And what that does is calibrate all these measurements under changing sunlight conditions so that you can really compare these data sets over time, which is, of course, where the real value in this data is. So looking at trends in your field. Are conditions improving? Are they getting worse? If you took some action, did it make a difference? Without that calibration component, you really can't make those comparisons. It's a very critical piece. The sensor technology itself, there are 4 channels there. They are what we call narrowband channels, so they don't overlap each other, and that gets into the sensitivity of our measurements. You can actually customize the location of those filters between about 410 nanometers and 950 nanometers with bandwidths down to about 10 nanometers, which can be very narrow. So we do have quite a few research customers that come to us with specific information maybe that they've collected from a hyperspectral sensor. They say, these are the 4 bands we care about. Can you build us a sensor? And so off we go, and you can still use SlantView in the same way. I mentioned the calibration. That's a very critical piece. We now have 2 patents issued on that technique. Those are issued patents, not pending patents. So, again, something we've been working on and perfecting for quite a while. And the last piece is onboard processing. So that's another component of how rapidly we process this data. But our processing workflow actually begins on board the sensor. The balance of that is finished, on the ground in our software, but there's quite a bit of heavy lifting that's done on the sensor itself. And we're constantly pushing more and more of our analytics capability onto the sensor. So there's quite a bit of room for expansion and capability given the onboard processing power that we have in these sensors. So the 3PX, this is our latest sensor. We developed this in partnership with DJI. There are a few, big advantages here. So number one, it mounts directly to the DJI gimbal port on the Matrice 200 series. So that's the 200, the 210, and the 210 RTK. And you can see there on the left, it just clicks right into that port like any other camera would. Makes it very easy to, connect payloads, swap payloads, no mounting brackets and plates and bolts. It just clicks right in. It also pulls power from the aircraft, so there are no external power cables, no batteries. It's very simple integration. But perhaps most importantly, there is now real-time communication between the sensor through the drone and down to the ground using the existing data link on the drone. And that's taking advantage of a new set of tools from DJI called the Payload SDK. I won't go too deeply into that, but basically it's a set of software tools that allows third-party payloads, so whether it be sensors or lights or package delivery, anything else, to communicate directly through the drone, just as a a native payload would. So it's a really nice set of tools, and I'll show you here how we put that to work. So this is DroneDeploy. Ian walked you through the app market. So of course we have an app in the app market, and this is the new version of our app. Many of you may have used our existing version. You can see now there's 2 tabs at the top. One for the sensor and one for the mission planning. What's shown here is our kind of customized front-end mission planner specifically for agriculture. So you can see, you can select what sensor you're flying. There's a calculate parameters switch there. So if you turn that off, you can manually type in your parameters as you normally would. So set your overlap, set your speed, set your altitude. But if you flip that switch over, it brings up this really kind of ag-centric flight planner. Where you can select the type of data collection you're doing, whether it's a population count in this case, or various other data collections. You put in a couple of parameters about the size of the plants, set your overlap, and then we give you some recommended altitude and speed based on those inputs. So again, it's intended to be kind of ag-centric, and rather than leaving it to you to decide how high to fly and how fast to fly, which you heard earlier are very critical parameters. We ask you some questions about the data you want and then give you some guidance on flight planning. So it's just a nice little front end that we put in, and of course all the back end is still handled by DroneDeploy. But if you switch over to the sensor view, this is all the new capability within the 3PX. Again, it's enabled by the DJI Payload SDK. So on the left there is the status of the sensor. As soon as you connect the sensor, the drone and DroneDeploy know that a 3PX is connected. It gives you the status. In this case, we're ready. It shows you the SD card usage, so if you're running out of space on your card. Those 3 LEDs are from, again, what we call our ambient illumination sensor, AIS. But those are real-time sunlight measurements that are displayed in the app. So if the sunlight conditions change, you'll know. Those will switch from yellow down to red if there's not enough light to do your data collection. And then on the bottom are a variety of options to obviously start the image capture. There's some sensor tuning options, which I'll show you in a minute. You can create logs from your flight. You can format the SD card. So really all kinds of real-time communication with the payload, again, just to ensure the efficiency of your data collection, the efficiency of your operation. As many of you know, I assume there's some SlantRange customers listening, but prior to this, the only real information you have about the status of the payload was a sequence of LEDs blinking on the sensor, which requires a decoder ring to figure out exactly what it's telling you. But now you've got this real-time information coming from the payload. So I'll walk you through what these various steps do. This is the calibration screen. So here you can calibrate the accelerometers, the gyroscope, the compass. There's a few other configuration options, but again, this is all done natively inside of DroneDeploy. This is the compass calibration screen. Many of you may be familiar with this, but you have to put the aircraft into various orientations to calibrate the compass. So they turn yellow for the position you need. Green means you've already done it. Red means it's still to be done. There's a progress bar at the top. So just walks you through that process. Once you start capture, you can see that ready state switches over to initializing cameras. So you'll know that it's initializing, acquiring GPS. It walks through a few different states. And then once you start capturing, you get a little pop-up. So it's actually capturing. You're getting your images. You're ready to go. You launch your mission. It goes through a standard pre-flight check. And then once you're flying, it's just like any other mission. And importantly, on the left bar there, you can see that the image counter actually increments just like it would with any other DJI camera. So the system is working, you're capturing the images, again, intended to really make sure you're getting the data you need and not spending your time if the sensor isn't configured correctly, if you're not getting the images. So again, kind of this real-time feedback. There are many more hooks in place that are supported by that payload SDK, including the transfer of actual imagery. So lots of new capability that we'll be pushing out over time, but this is the current implementation in DroneDeploy, which again is a whole host of new information that previously wasn't available. So pretty powerful integration. I do want to show you one other app that we integrated with. This one is called Flight Plan for DJI drones. It's kind of a native integration here. Very similar features. So on the top left is the status of the drone. On the top right is the status of the sensor. So again, you can see the status message, the SD card, the number of GPS satellites. We have our own GPS on board the sensor, so that's the GPS status of the sensor itself. You can see those AIS measurements at the bottom. So very similar interface. One additional feature that we did add in this case was displaying footprints of the images on the ground. So you can verify your coverage as you're flying. Make sure you're not getting any gaps in your imagery. Obviously, sometimes under very high winds, the aircraft is pitching and rolling, and you may end up with gaps. So this is a nice way to verify that you're getting the coverage you expect. And again, you can see the image counter there at the bottom. So again, all real-time information coming from the sensor as you're flying, and this is specific for the DJI M200 series. So with that, I'll do a quick summary here. I walked you through SlantView and some of the benefits that we offer. Again, we're very focused on efficiency and scalability, and how do you take these data products and number one, create an efficient business out of it, but make it scalable, literally across the globe. I mean, with this offline data processing technique, we have people using our systems, all across the globe, and especially in places where you may not have an internet connection. So this offline processing is important. Following that, of course, once you have generated those maps, we have full DroneDeploy support. So you can take those maps, take them up into DroneDeploy, use all other great tools for syncing and sharing and archiving and annotation. So it's a really nice partnership there. Moving beyond NDVI, we talked about this. It looks like a lot of you folks are interested, so that's great. But we are, again, focused on some very high-value data products that you really can only get from this type of imagery. Number one, the multispectral aspect, but also, this very high-resolution data that you can get from a drone. And then lastly, I, gave you an intro to the 3PX. It's really a combination of, what we think is best-in-class multispectral sensing and analytics, coupled with what we would think is probably the leader in the space and the aircraft. So it's, kind of delivered on this trusted platform. And I walked you through, that full app integration that's now on DroneDeploy. The 3PX is shipping now. So if anybody's interested, please contact us. And on that note, here is my contact information. You can reach us anytime at sales@SlantRange or support if you're a current customer. And I will do a quick plug for our blog. We've got a new blog post up just today that really starts diving into the details of, kind of the data value of some of these different imaging platforms, touching on resolution, as I mentioned. It's actually going to be a multi-part series, and part 1 is up today, so take a look. Thanks very much.
All right, thank you, Matt. So as we move forward and about to start the Q&A, I did want to let everyone know you just got to see a lot of the exciting hardware and software that is compatible with DroneDeploy, but how do you put that to work? So we're going to talk a little bit about our latest Precision Ag package, which is one of our new offerings here at DroneDeploy. It really allows ag professionals to get the software and the tool set that they need to make the decisions on the farm that are going to help them be successful. So in addition to what comes with our normal pro level, you get a real-time live map, which Ian talked a little bit about earlier. This helps you do rapid crop scouting in the field, whether you're offline or not. You also, you heard from Agremo, it comes built in with up to 1,000 acres of Agremo stand count and plant population analyses. So that's a really exciting feature. It's also going to come with the advanced crop health toolkit, which allows you to toggle between algorithms like NDVI or Vary. You can create management zones, and you can change sensors and utilize those such as SlantRange. And of course, it's going to come with the plant health shapefile export, which is going to allow you to export your data to your preferred farm management software. Maybe you're using John Deere or other ones that are compatible with DroneDeploy. So with that, we're just wanted to mention that you can get started mapping for free with DroneDeploy. You can sign up on our website, download us on the app stores for Android and iOS, and start utilizing some of the software and hardware you saw today. And we all plugged our blogs, and I work on the marketing team, so I'd be remiss if I didn't. You can always check out our blog to read about customer case studies or highlighting some of the new exciting features we have. And we also have a complete resources page that has things like these webinars, as well as ebooks, white papers, case studies, and more. So you can check those all out on your own time. And I did want to let you know I did provide 2 handouts to everyone who joined today. You can access them in the handout section of the GoToWebinar control panel. There's 2 ebooks there. One, a high-level overview of how you can use drones in agriculture if you're new, as well as a more advanced one on crop scouting with drones that mentions some of the software and hardware that we talked about today. So with that, I'd like to go ahead and kick off the question and answer session. And while we did get a lot of questions, we're going to try and answer as many as we can in the few minutes that are remaining. So the first one I'm going to go ahead and ask here is for Milan. So Milan, one of the attendees today is interested in, they want to know, are these models calibrated with ground truth data? And also, can Agremo analyze cotton crops?
Yeah, first, thank you, Darren. I'll answer the easier question, the shortest actually answer first. So yes, for cotton crops, definitely. I know that we analyzed, I think it was plant counting for sure. For stress analysis, definitely yes. I would need to check exactly which type of analysis. For the first question, whether it's correlated to the ground truth, yes, of course. First, I would say it's a 2 or 3 step process by which we make sure that we are getting the accurate results. First, of course, in the R&D phase, is that we are putting a lot of efforts to know based on what kind of image of which quality and for which crop are we able to get the accurate results. But the thing is actually that since we don't process and analyze just a single or few crop types, there are many crop types that we don't have so much. We cannot assess it by our R&D teams to go on the field. And this is then in this step actually we do it together with our users. So sometimes we are asked, can we do this or that analysis with this crop type? Then we say, yeah, I guess yes, but let's check it together if we can achieve what you need, because there are many crop types that again we have to figure out what exactly which phenomenon on the image can we detect and how to correlate the spectral signature. I think Matt was explaining it earlier to the phenomenon that we are looking for on the ground. So sometimes it's checked a posteriori based on the result that we achieve, and this is where the feedback of our customer or our users are very valuable. But what is very important is that we put a lot of accent to the accuracy, and if we cannot achieve it, then we tend not to perform the analysis, or at least not to charge the users for that. So coming to sum up the answer, yes, we always check it with the ground truth when the data is available and when we can get to the ground truth data.
Excellent. Thank you so much, Milan, for answering that question. The next question is going out to Matthew. One of the attendees is interested in learning what sensor was used for the test plot analytics that you showed earlier to get the plant population density and plant size, and also can SlantRange differentiate between such things as manure and soil in a field after manure has been spread?
Yeah, sure. So the first question, that data was collected with our 3P that was collected last year for one of our contracts. Just to point out, the imaging core, kind of the imaging functions of the 3P and the 3PX are very similar, if not exactly the same. So the 3PX adds on these integration capabilities, but the imaging core is the same. So that was collected with the 3P. We've had a small number of inquiries about manure. Given our kind of offline data processing mode, we almost, we don't always have direct insight into what people are doing. We personally haven't done any, distinctions between soil and manure. My gut says there probably are some spectral differences, and if they're in the bands we cover, it would certainly work. But yeah, as Milan said, it's something we'd probably have to try with you.
Great. And then one more quick question here for you, Matthew. This attendee is wondering, will SlantRange sensors work with the M100, the M200, or other drones such as the M600 Pro?
Yeah, so that's it's a tricky question. The hard line from DJI is no, but we have confirmed that they will mount in those connectors and they will pull power from the aircraft. It's certainly not supported by DJI. But the M200, to be clear, is the only one that includes this real-time data communication. But as far as physically mounting the sensors and pulling power from the aircraft, some of those others they work. Maybe not fully supported by DJI, but yeah, it will work.
Okay, great. This next question is for Milan. What is the error in the Agremo analyses? Is the analysis relative to other plants in the field, or yield data for plant types in that area?
I guess you're referring, thanks, Devon. I guess it's referred to a stand count analysis. So basically, the question is, if I understood correctly, related to the difference of the analyzed stand count comparing to recommended or the planted. So this is the information basically which is provided by the user, and based on which we, when we identify the low performing or high performing or mid performing areas on the field, then we can correlate and calculate the difference between the expected the stand count based on this provided information. Now, just to add on that, if by chance the question was related to the accuracy, not to the difference in the stand count. So typically, what we consider as not good enough information is everything which goes below 95%, and we are usually achieving the accuracy results 98, 99%. And of course, it depends a lot on the crop type being analyzed. It depends on the growing stage, and of course, it depends on the quality of the image. But so we always try to get the results asked by the user, because sometimes even less accurate information is better than none. But we don't consider the everything which is below 95 or even 96, 97% to be accurate enough.
Excellent, that's great to know. And with that, folks, we've actually run up against our time here, and I want to be conscious of everyone's time. So I want to just say thank you to our organizers, and panelists today, and to everyone for joining. And I will mention that, while we didn't get a chance to get to everyone's questions, we had so many, I will provide our panelists with the questions so they can follow up individually if they have time. So Milan and Matthew can look out for an email from me. But with that, I'd just like to say, thank you to everyone, especially our panelists, for taking time out of their busy day. I hope you found this webinar to be informative and have a better idea of how you can actually generate those actionable insights and take that and turn it into results on your farm or for your customers. So with that, is there anything else you gentlemen would like to say?
I don't think so. Thanks very much. Yeah, appreciate it.
Yeah, just to thank you. Thanks everybody for joining us, and I really appreciate it.
Yeah, thanks everybody. Any integration ideas, thoughts, workflows, things that are hard to do these days, would love to hear those. If you can pass them on, think of something cool, interesting, exciting that would make your job easier on the field, then let us know. We'd love to hear it. Thanks.
All right, have a great day, everyone. We're signing off.
Take care. Bye-bye.
Bye.